Hello everybody, and let's get back to the weather quiz. So this is the quiz we were working on in class on Wednesday, November 7th. And as I promised, I was gonna finish working on this and give you the solutions to this. What you're not getting online are the solutions to the midterm review. Those I will also record in a video, and I will give that to Freddie, who gladly volunteered to be present next Wednesday, November 14th, and he's going to play the video for the class. All right, so we did number one in class. That was the frost question that is disrupting the airflow, and it's actually decreasing. Let's see how this works. And it's actually decreasing the lift capability. So number one is A. And we also did in class number two, which was actually C. We said that actually all these options are correct options, but C is the best one because the movement of air happens, yes. The pressure differential happens, yes. But they are both due to that unequal heating of Earth, and the process that creates that wind and creates that pressure differential is actually heat exchange, and this is why C is the best answer. Now we skipped 3 in class, so let's actually look at this one first. It says the wind at 5,000 feet AGL is southwesterly, so it's coming from southwest, while the surface wind is southerly, so it's coming from south. So there is a difference in direction. One is southwest at altitude, and then the other one is coming from the south at the surface. But why do you have this difference in direction? And you have 3 options: stronger pressure gradient at higher altitudes, B is friction between the wind and the surface, and C is stronger Coriolis force at the surface. Now, if you remember any of the content that I covered for you in class on Monday in the weather theory, you probably have not heard of Coriolis force, which is an acceleration due to Earth rotation. That option is the first one you want to reject right off the bat because either you have never heard of it or it does not sound right. And the Coriolis force is not stronger at the surface, by the way. So you have 2 options. You have stronger pressure gradients at higher altitudes, which is the case. We talked about the fact that high altitude weather is actually governed by those high pressure regions and low pressure regions. But this doesn't really tell you much as why the wind direction would change. What really happens, and what we also talked about in class, is that close to the surface, you're gonna have friction with the ground and also the presence of buildings that tend to change the direction of wind. So the actual answer in this case is B. Let's go to number 4. This is, and remember what I said in class. So for those of you that are watching this video but were not in class on Wednesday, November 7th, the idea of this weather quiz is not something that I will give to you as a quiz. My thinking was that the best way to learn weather and how to do well in the weather quizzes is actually to provide you with a bunch of questions and tell you the rationale behind each answer. So I gave you the overview of weather theory, I gave you the overview of weather services, and now we're gonna look at the details through questions. Of course, you're very encouraged to do 2 things. One is open your homework 5 and you will see a link to a video on weather services, so that's definitely a good resource for you. But also use Gleim and test on the weather unit to actually get a lot of this going. I am not gonna quiz you on stuff that we're not covering together. So both the YouTube video and Gleim will have a lot more details on weather than what we actually cover in the class, but I'm not gonna ask you about those. But it is a good resource for you, especially for those that wanna, become pilots and do the FAA exam. All right, so number 4 is another one of those questions of things that we have not discussed yet. And it asks you what are the processes by which moisture is added to unsaturated air. So remember that idea of the temperature and dew point? That assumes that moisture is kind of there. And when you have the temperature equal to the dew point, you have fully saturated air, which means you cannot increase the moisture content. You cannot increase the water vapor in that air. So what happens when you actually have unsaturated air? Unsaturated air is air that can still build up on its moisture content, on how much water vapor is included. So what are the processes by which moisture is added to unsaturated air? They're actually evaporation and sublimation. So you probably don't know much about sublimation. You probably have heard of condensation. You might not have heard about supersaturation, but for sure you have heard about evaporation, especially if you're cooking. You know, I'm Italian, I love pasta. So every time I cook, what happens? We have the evaporation, and then eventually you get a water vapor on your stove. But the idea is that moisture is going to either come from water that evaporates to the gaseous state, or vice versa. That's the sublimation process, if you're passing directly from ice to water vapor. That can also happen. Okay, so that's the two processes, from liquid to gas and from solid to gas. Okay, number 5 is one of the questions that you should know how to solve, okay? And that was the moist, stable air that is flowing upslope. So this tells you already that it's stable, so you want to look at the qualities of stable air, and we have lecture 19 PDFs on Canvas for that. But it's not just stable air, it's stable air with moisture content. So that has the opportunity for clouds, for fog, for rain. So all of those talk to you about clouds and rains, and this one is turbulence, so this is not it. But the idea is understanding which type of those is actually associated to stable air, which is actually option A, the stratus clouds. Remember that stable air with appropriate moisture content will create the horizontal development clouds that are called stratus clouds. The showers and thunderstorms are not okay because stable air would have continuous rain, not showers, and the convective turbulence, again, it's related to unstable air once more. Number 6 we did in class, and the answer was B, it's 10,000. And for those of you that did not come to the lecture, how you got this was doing 82 Fahrenheit, which was the temperature at the surface. Subtract from that the dew point, which is the temperature at which the content of water vapor is maximized, and divide that by the lapse rate, which is in Fahrenheit 4.4, and you get 10,000 feet. Now note that this is in Fahrenheit degrees, Fahrenheit. If you have Celsius, this is different. If you have Celsius, which is not spelled like that, Celsius, you have to use 2.5. So you would do the temperature in Celsius minus the dew point in Celsius and divide that by 2.5. So this is the lapse rate. All right. Let's move on. Number 7. What clouds have the greatest turbulence? And I talked about this on Monday's class, so you might remember that the cumulonimbus is the one that you want to be mindful for. It's a cumulus cloud, so unstable vertical development, and it's nimbus, which means it's going to have a thunderstorm, rain, and a possibility of wind shear, okay, turbulence. All right, so let's go to number 8. One of the most easily recognized discontinuities across a front. This is also another one that you probably should know if you were in class on Wednesday, and that would be a change in temperature. Change in cloud coverage is not necessarily associated with a front passage, and also an increase in relative humidity is not necessarily part of a front. But a change in temperature, that's the very definition of fronts. Okay, front is the boundary between two air masses that have a different temperature. All right, 9. When may hazardous wind shear be expected? Remember, wind shear can happen at all altitudes, can happen because of a thunderstorm activity, but it's the idea that you're going to have a sudden change in both wind direction and wind speed. If you remember, we talked about wind shear on Monday, November 5, so the lecture on weather theory, and we said that it was related to low-level temperature inversion. It could be related to frontal zones, and typically you have clear air turbulence. So visibility is good. You're not able to actually see that wind shear is going to be present. It's not like you're going to have a loss of visibility or something visual. So the answer here is B, with the low level temperature inversion being the key to wind shear. And if you don't remember what temperature inversion is, it's that effect by which the surface of the ground is actually warmed up. Sorry, that's a heat from below. The temperature inversion is that situation in which you have kind of an opposite lapse rate. So it's a situation in which as you move up, the air gets warmer. That's what temperature inversion means. So the standard atmosphere tells you that as you move up, air becomes cooler. And that is also what typically heating from below promotes. Temperature inversion is the opposite. And so basically has a different trend of temperature with altitude. Number 10, if the temperature dew point spread is small and decreasing and the temperature is 62 Fahrenheit, what weather is most likely? So we said many times, both on Monday and Wednesday, that the temperature dew point spread small, particularly less than 3 degrees, means you have the possibility for fog, you have the possibility for clouds, haze, and all that bad visibility, possibly bad weather. The temperature 62 Fahrenheit tells you that you're not at a freezing level yet. So freezing precipitation is not going to be the answer because you're actually above freezing. Thunderstorms are not really related just to the temperature dew point spread, so the answer right here is C. All right, TAF, Terminal Aerodrome Forecast. We did some very nice exercises on this in class. So here on the bottom you have your TAF for Memphis and for Oklahoma City, and is asking you for the clear sky becomes overcast at 2,000 feet with some forecast, overcast at 200 feet with some probability, and overcast at 200 feet with some other probability. And the difference of these two is the altitude of the overcast layer. So we're gonna first off look at the TAF for Oklahoma City, which is the green one, so forget all this portion, and you want to look for clear sky that becomes overcast. So I am looking here. This is again the date and the time of issuance. This is the validity period. This is the wind. This is the visibility, baby rain, so mist, broken clouds, and then what's going to happen temporarily on the 5th between 1 p.m. and 4 p.m. You have reduced visibility, you still have mist. Then from the 5th at 4 p.m., this is your new wind. This is your visibility, more than 6 statute miles. Here it is, sky clear. Okay, so we found our clear sky because the question asked the clear sky becomes something else. So you look at this, the clear sky is becoming what? On the 5th, between 22 Zulu, so 10 p.m. to 24 Zulu, so midnight, you're going to have gusts. You're going to have visibility for statute miles. You're going to have shower rains. And here it is. You're going to have overcast at 020. Remember, you have to add 2 zeros. So it's going to become overcast at 2,000 feet for the forecast on the 5th between 22 Zulu and 24 Zulu. So your answer is actually A. B and C, you could actually reject right off the bat, because if you directly find this OVC, overcast 020, you know this is overcast at 2,000. It's not overcast as 200. So you could have rejected B and C right off the bat. All right. Number 12 is again related to TAF. And what is the valid period for the TAF at Memphis? So remember what to look for. Memphis, this is the issuance. So 12, 17, 20 Zulu, 12, 18, 13, 24. So this first one is tricking you. It says 12, 18 Zulu and 13, 24 Zulu time, which is using the same numbers here. But remember that the first number here is the date. So it's from the 12 at 18, which is 6 p.m., until the 13th day of the month at 24, which is midnight. So the answer here is B. Okay? This one is also tricking you because it's using the 12 from the date. So this is the Memphis TAF issued on the 12th date of the month at 5:20 p.m. Zulu time, and its validity is on the 12th starting at 6 p.m. and then up to the 13th at at midnight 24, which is 12, well, 00 a.m., however you call it, 12 a.m. p.m. I'm not sure in English, but midnight. All right, number 13. Number 13 says, refer to the significant weather prognostic chart. What is the forecast for the Florida area ahead of the stationary front during the first 12 hours? So this is a lot to take in. So before we actually answer this, I want to show you this chart. And this is why we have it here on the slide. So actually, let me make it bigger. And I'm actually going to zoom on that. This is called the weather prognostic chart. And as you see, it has 4 different segments, so 1, 2, 3, and 4. These 2 ones on the left side are the 12 hours significant weather. These 2 ones are the 24 hours significant weather. So you see here 24 and a 24, and likewise you see a 12 here and a 12 here. So if you look at the question, is asking you, look at the significant weather prognostic chart, that's this whole chart. He wants the forecast for Florida ahead of a stationary front during the first 12 hours. So because it says during the first 12 hours, we want to look at these 2 panels and not these 2, okay? Now, you want to look at Florida, which is this state right here, and it mentions a stationary front. See it here? This is a stationary front, okay? What is the difference between the top and the bottom? Sorry, I forgot to tell you. The top ones, the 2 top ones, it says SFC 400. So this is the surface weather, and these 2 are more related to high-level synopsis. And so these 2 are the ones that show you high-pressure regions, low-pressure regions, and fronts. These ones are more related to ceilings and visibility. So if you actually look in the Florida area, you see the stationary front right here, okay? And you see a bunch of different things, and now you want to combine both this chart and this chart. You see that ahead of the front right here, this one tells you that there is a bunch of rain, so all those dots remembers the symbols that we looked over in class, and they are at the very in the very back of your weather quiz. So online you can find them also on the slides right here. So this is the continuous rain, this is a continuous rain, this is continuous heavy rain, this is moderate, and this is the intermittent one. So going back to our chart right here, you see continuous rain on the moderate side, and this is thunderstorms. That thing that looks like an R, it's actually kind of the symbol of a lightning if you look at the symbols that I gave you the handout in class, and that is the thunderstorms. But if you actually look in this region right here, what you see is these, for this portion of Florida, you see these green line, dashed line, and you see these like nice green, blue circled line also for Florida. So Florida is here, this is where the front is because of this picture, and you see these 2 lines right here. So if you actually take a look, the green dash line is the freezing level, that it's above mean sea level. So that's actually something that you want to be mindful of. The blue scalloped line means that the ceiling is between 1,000 to 3,000 feet inclusive, and the visibility is 3 to 5 miles inclusive. Okay, I know it's kind of hard to read, so you will need to actually super zoom on it, but this is what you would see. Okay, so let's go back to the slide view here. So if you go in our question and look at the answers, answer A is actually just asking you that. So you have the ceiling between 1,000 feet to 3,000 feet, and the visibility is 3 to 5 miles, and you know because of this scalloped blue line, and the continuous precipitations you actually know because of these symbols right here. The ceiling less than 1,000 feet, that is the red region, which you see here, and that's not Florida. And this bottom one says intermittent precipitation. If you had intermittent precipitation, you would have the vertical symbols for rain, which is not the case. All right, 14 talks to you about a wind and temperature aloft chart. So let's actually take a look on our slides. This is the wind and temperature aloft chart, and it's the same one you have in your weather quiz. So a wind and temperature aloft chart is a table that gives you wind and temperature at altitude. So here it says FT, this is feet. This is the feet of the altitude. So this is 3,000 feet, 6,000 feet, 9,000 feet, 12,000 feet, and so on. And aloft means just at altitude. So each of those actually gives you the wind direction and the wind speed and the temperature. So the way you read this, we're actually going to study more in detail when we do navigation. But the first 4 numbers, those are actually direction and speed of wind. And then in some situations, you see these plus 00, minus 04. So the plus or minus indication right after, that's the temperature. So you have both, well, actually you have 3 information. You have the wind direction, you have the wind speed, and then you have the temperature. You're going to see that there are some gaps. So sometimes there is nothing provided, and other times there is no temperature provided. If the temperature is not provided, that means you have the standard temperature. And one thing that you actually want to look here is this, what the question is asking is actually why you have holes here and there is nothing provided. So here it says the 3,000 and 6,000 data for Denver is not displayed. And so one thing that I did not mention is that you actually have a bunch of different airports. Denver is Den, so you see right here, this is the line for Denver. And this is St. Louis. I honestly do not remember what the other airports are. But it says 3,000 and 6,000 data for Denver is not provided. Why is that the case? And it provides you option. There is no significant weather, and so we're not going to tell you what the wind and temperature is at 3,000 and 6,000. B says the local elevation of Denver is such that the first aloft forecast is the one provided for 9,000 feet. And C is we don't provide it to you because we have the same condition as that of 9,000 feet. So basically we'll copy paste this information also in the other buckets. So hopefully it comes as no surprise to the American based, but it may be a surprise for the other ones, that the answer is this one. So Denver is actually located roughly, Denver Airport is at roughly 6,000 feet. So they cannot provide you temperature aloft, so temperature in the high altitudes for 3,000 and 6,000 because Denver is at 6,000. So the first elevated data point that they can get is 9,000. And so this is why option is B. For the wind portion, you read it the same way. So this would be a wind from 270 at a speed of 14 knots. So it actually has one less digit for the wind direction, and so you want to be mindful of that. So let's look at this one, for instance, and let me zoom on it. So this one says 2325. It's not wind coming from 232 at 5 knots, is wind coming from 230 at 25 knots, okay? And, you know, it wouldn't make sense. Look at this. Wind coming from 233. Who has that precision up to the degree for the wind? The wind is given pretty much to increments of 10, 230, 240. Nobody's going to tell you 232, okay? This is how they trick you with questions. All right, next up is this guy right here, which is an area forecast. Now, for those of you that are pilots, you may know that area forecasts starting last year have been replaced with a very nice chart. So now there is like a map of the US, and that replaces the table format of the area forecast. But still, we're going to give it a shot as an exercise for weather services. So area forecast is similar to a TAF, if you will. It includes, of course, a forecast. It's called an area forecast, but also includes a synopsis, which is, again, a very general indication of weather for a region. An area forecast is called area forecast, so and actually is indicated as FA, not AF, although it's area forecast. For a big region. So if you actually take a look at this area forecast, it says here UPR-MI, that stands for Upper Michigan, Western portion, Eastern portion, Lower Michigan, Central North, Southern Third, Indiana. So an area forecast has about 3,000 square miles validity for any of those, and includes, again, weather forecast and this synopsis that kind of summarizes everything weather related. So it's asking you the sky condition and visibility forecasted in Upper Michigan Eastern region after 23 Zulu. So you want to look at Upper Michigan Eastern region and then after 23 Zulu. So Upper Michigan is here, UPR-MI, that stands for Upper Michigan. Then you have Western portion and Eastern portion. So it's asking for the Eastern region, so this is what we want to look at. And it says after 23 Zulu. Remember, this is a forecast, so it's going to have different times of the day. And you see it here, 23 Zulu on the second line of the Eastern portion for Upper Michigan. And it says overcast. At the ceiling, it's going to be overcast at 1,000 feet, and the visibility is 3 to 5 statute miles. So let's look at the options, and hopefully we're going to find one of those. It says ceiling at 100 feet. No, this is not 100 feet. This is 1,000 feet. So A is not an option. B is ceiling 1,000 feet and visibility 3 to 5. Yay, but it says nautical miles. This is statute miles. So the option that is correct is actually C, ceiling 1,000 feet and visibility 3 to 5 statute miles. So hopefully you are getting better and better at understanding how these work. You don't need to decode the whole thing. That's going to take a long time, and even I am not capable of decoding all of it. So what you want to do is take a look at the options, take a look at what the question is asking, and just try and look for that information. Overcast 1,000, okay, A is not an option. You don't even need to read this, because you know that 100 feet doesn't make any sense. It's never going to provide you with information at 100 feet. And also, you should know that we're not using nautical miles. You've seen enough of those on Wednesday that you know that the visibility is provided in statute miles. Last question for this quiz is the outlook for the central portion of Lower Michigan is. So if you go in the Lower Michigan, now Lower Michigan is here, and it's asking central portion, and it says outlook. You may not remember what outlook is. We talked about this in class. Outlook is a forecast for more than 6 hours. So actually on the second line, OTLK stands for outlook, and it says outlook is the IFR ceiling with mist. So IFR means you want to go with instrument flying conditions. You're not going to be allowed VFR flight. So the answer is actually A. Okay, so hopefully this was helpful. And again, don't feel bad if you don't know how to answer this. This is exactly my purpose. I wanted to show you questions that you don't know the answer to, showing you how you actually go about solving these questions and decoding some of this information. Okay, now good to know for your exam. This is the weather model that we kind of covered in class on Wednesday, and the symbols that I mentioned. The model for a weather station and the symbols can be encountered, especially the symbols here, in the weather prognostic chart, or they can be encountered in another type of, we talked about all of this in class, but in another type of chart, which is this one. It's called the weather depiction chart. So you see all those actually clear circles. Those are your weather stations. Some of them are partially, have a partial blackened out quadrant. And that's because what happens is you can have a few clouds, or you can have scattered clouds when you actually have the line, or you have broken ceiling, or you can have, overcast and complete obscuration. So typically they will give you a state, and this is nice enough that they actually provide you. So I finally know that this is Kansas, but if they don't provide you the names of the state, it gets harder. Then say, okay, in northern Kansas, weather stations are reporting sky clear, sky obscured, and so you know how to read those symbols. Now, the most typical question for a weather depiction chart is actually related to these shaded areas that you see right here, and you see some fronts. So fronts can be included here, and as I mentioned, they're in black and white here. So you know that this is what? Your warm front. This is a cold front. But the shaded areas, it's actually provided right here. See, they say shaded areas is IFR conditions with ceilings that are less than 1,000 feet and visibility less than 3 miles. The contour without the shading, so like these lines right here, those are marginal VFR areas with ceilings that are greater than or equal to 1,000 feet, but less than or equal to 3,000 feet. Okay, so remember, the first thing that you want to do is look at the information that is provided on the chart. One of the questions that I've seen in my test is, what chart is this? And you may not remember all the names of the charts, but it's actually written right here. This is a weather depiction chart. So they're actually providing you with all the information that you need to give the answers. Stuff that is not provided, I just told you what the model station is. So if you don't know that this is clear, that this is obscured, that this is broken, and this is scattered and few clouds, that's something you need to learn by heart. Another thing that is not provided is the symbols for the rain. So you want to make sure, and you want to make sure that you know that these things are wind and the direction. I have never seen a question that tells you how strong is the wind. It's good information for you to know, especially for the pilots, but I have not seen questions about that. All right. So this is as far as I go for completing the weather quiz. And again, I'll make another video with the solution for the midterm, but that I will only email to Freddie, who volunteered to show it to the class next Wednesday. So I do hope you have a good Veterans Day. Remember to work on your homework 5 that is due the same day of the midterm. And stay tuned for our next class on Wednesday. I hope that you all participate to the class, that you actually get some good discussions going with the midterm review, and then of course you also get the solution. All right, bye and enjoy the long break from seeing me.